Container ships are a special type of cargo ship designed to efficiently transport standard cargo containers. We often see cargo containers on large trucks on the road. Let's look at the general design of a container ship. The size of container ships is usually determined by their capacity in 20-foot equivalent units and 40-foot equivalent units. Container ships store fuel in tanks usually located next to the engine room or in tanks on either side or bottom. Ballast water tanks help to stabilize the ship. Most ships are equipped with hatch covers. Ships store containers inside the hull and on deck. Inside the hull are cargo holds. Cargo holds are divided into compartments by watertight bulkheads. A complete hold is divided into two parts using what is called a pillar bulkhead. In recent years, the cargo holds on most container ships have been designed to handle 40-foot containers. A small ship can carry less than 1,000 TEU, and the largest ships can carry more than 24,000 TEU. On a smaller ship, the superstructure and engine room are located at the rear. On a larger ship, the superstructure is located towards the middle of the ship. On a very large ship, the superstructure is separated from the funnel and engine room and is designed towards the front. The reason for this is to increase visibility from the bridge and to allow for more containers to be stacked on top. The containers are designed to be stacked on top of each other. This is a type of corner lock. The containers are connected together by a device called a twist lock. This is a manual twist lock. It has a lever handle that can be moved sideways to tighten them into place. It locks the corner locks of two different containers together. This is a semi-automatic twist lock. The cone on this lock is designed to be slightly tilted to one side. So when the corner of the molding is pressed down, the cone automatically rotates and then locks in place. To unlock, the operating rod is used to pull this rope by hand. Now you can see the containers stacked vertically. The same twist lock mechanism is also used to secure containers on trucks, but sometimes people still choose to do it this way. How to store containers? These are sail braces. Containers are stored along the sail braces. When storing 20-foot containers, they can be at risk of sliding to one side. The corners of the containers that are not supported by the sail braces need to be secured to prevent them from sliding to one side. At least one or more 40-foot containers are usually stored above to prevent the 20-foot container from deforming. Containers stored inside the hull do not need to use twist locks. When the hull is fully loaded, the hatch cover is closed and more containers are loaded on deck. Since there are no sail bracings here, the containers must be secured with twist locks. However, twist locks alone are not enough. Lashings are needed. This is a bridge. The lower levels of containers need to be secured to prevent movement and minimize structural stress. To maximize the ability to handle containers on deck, the stacks of containers off deck are often supported on platforms. Container ships can carry large quantities of refrigerated containers, commonly known as reefers. Nowadays, all containers on ships are secured and ready for voyage. Even with careful safety measures, sometimes errors occur and can lead to accidents like this. Loading and unloading containers on and off ships requires a giant port crane called a container gantry crane. The gantry crane lifts the container with a spreader. This device uses twist locks to secure it to the four molded corners of the container. Once the lock is secured, it can lift the container and load it onto the ship. The spreader is equipped with image sensors to help accurately position the container. Unloading and reloading containers onto and off the ship usually takes 1 to 3 days, depending on the volume of cargo. So, how is a container arranged in these giant stacks? This is the number of compartments. Odd-numbered compartments are for 20-foot containers, and even-numbered compartments are for 40-foot containers. This is the number of rows. Starting from the middle, odd numbers are on the starboard side and even numbers are on the port side. And this is the number of floors. So when the position is 300,414, it is a 40-foot container loaded in compartment 30, row 4, and floor 14. In the digital age, AI is revolutionizing the maritime industry, turning giant ships into smarter and more efficient operating systems. AI is not just a monitoring tool, but also an optimizing brain. Machine learning algorithms are used to optimize cargo placement, ensuring maximum space in containers and onboard ships. For reefers, AI continuously monitors key parameters such as temperature, humidity, and CO2 levels. If there are any deviations, the system automatically sends alerts, protecting sensitive shipments such as food and pharmaceuticals. Here is one of the most important applications of AI. Systems like Orca AI use image sensors and computer vision to provide enhanced situational awareness, especially in low visibility conditions or in busy traffic areas. This system can detect and classify surrounding objects, other ships, buoys, debris, predict the trajectories of other ships, provide collision warnings, and suggest evasive actions. The industry is even moving towards maritime autonomous surface ships, MASS. Several autonomous container ships have been successfully tested, using AI to navigate, detect obstacles, and plan routes without direct human intervention. Instead of waiting for machinery to fail, AI analyzes data from thousands of sensors on engines, pumps, and electrical systems to predict when a component is likely to fail. This allows the crew to perform maintenance before a breakdown occurs, minimizing downtime and expensive repairs in the middle of the ocean. Losing containers in storms is a major risk. To help these giant ships weather major ocean storms, designers and engineers have equipped them with many advanced technologies. Modern ships use advanced weather routing systems. These systems integrate global weather forecast data, wave models, ocean currents, and the ship's hydrodynamics to calculate the optimal route. The goal is not only the shortest route, but also the safest route, helping the captain completely avoid areas with storms or large waves. While the enormous size of the ship gives it natural stability in a major storm, the following systems play a key role. Anti-rolling tanks. Water or oil tanks are located on either side of the ship. When a ship tilts, the fluid automatically moves to the opposite side to create torque to counteract the sway of the waves. Fin stabilizers are hydrofoils similar to airplane wings mounted under the hull. They are operated by hydraulics and computers, automatically adjusting their angle to create lift or downforce, significantly reducing the roll of the ship when moving. Modern container ships are designed with extremely high watertight integrity. The hull design is optimized to withstand extreme stress from ocean waves, especially slamming when the bow of the ship hits the water after rising high. Stress sensors are installed on the hull to monitor material tension in real time, allowing the captain to adjust speed and course to protect the ship's structure in harsh conditions. The maritime industry is shifting to greener solutions. To reduce carbon emissions, many new container ships are being powered by liquefied natural gas, LNG. LNG significantly reduces sulfur oxide, nitrogen oxide, and CO2 emissions compared to traditional heavy fuel oil. Some new ship designs are reviving sail technology in a modern form. Flettner rotors are large rotating pillars on the deck of the ship. When the wind blows over them, the Magnus effect creates significant thrust, reducing the load on the main engines and saving fuel. At ports, AI and automation are also speeding up the loading and unloading process. Ports use the SmartGate AI system to automate the container handling process at the port gate. The technology uses optical character recognition, OCR, and AI to read container numbers and truck license plates, reducing gate staff by 100% and reducing traffic congestion. The new generation of container gantry cranes can be operated remotely or fully autonomously, using laser sensors and precise GPS to position containers with millimeter accuracy. From a basic means of transport, the container ship has become a high-tech machine where AI and advanced maritime engineering combine to ensure safety, efficiency, and sustainability. Understanding these technologies not only helps us appreciate the marvel of engineering, but also opens up the future of the maritime industry.